Hello, this is Icon, and today I'm going to show some limit theorems. And I got 4 in total. And number 1 is the sum rule. Number 2 will be constant multiple rule. And the third one will be product rule. And the fourth one will be the reciprocal rule. And by 3 and 4, we can have the quotient rule. So quotient rule, I didn't write on blackboard, but actually we have it. Okay. So I'm going to show the sum rule first. Actually, these 4 theorems based on the fact that limit x to c f of x is L, which is a finite value, and limit x to c g of x is m, which is also a finite value. Then limit x to c f of x plus g of x will be L plus m. Okay. So we're going to show these listing, and we have the definition, right? We have the definition that we want f plus g minus we want this to be less than epsilon. Okay, we want this to be less than epsilon. So we can start from this absolute value and start it with a triangle inequality, which means f plus g minus L minus m equals f minus L plus g minus m, right? Then apply the triangle inequality. Okay, so parenthesis, okay. And since given this 2 condition, so we can have that there exists delta 1 in this inequality, then satisfies f minus L, f of x minus L, which is less than epsilon over 2. And you may wonder that why here will be epsilon over 2. But actually here you can take any arbitrary real number. And epsilon is a real number, so epsilon over 2 is also a real number, positive real number. And also there exists delta 2 in this inequality, such that g minus m, which is less than epsilon over 2 as well. So by these 2, we can conclude that this is actually less than epsilon over 2 plus epsilon over 2, which is equal to epsilon. Okay, therefore, the statement holds. Okay, so this is the sum rule. So the next one will be constant multiple rule. And constant multiple rule says that if limit x to c f of x is L, then limit x to c k times of f of x is k times of L, while k is a real number. Okay, so this is quite trivial because this is the given condition. So we have the fact that f minus L is less than k over, epsilon over k, while k is greater than 0. So we have three cases, right? K is greater than 0, less than 0, and equal to 0. Okay, so we can multiply both sides by k. So k times of f minus L is less than k epsilon over k. And put this k into the absolute value, so we can have the conclusion that this holds. Okay, so this is the first case. Then the second case, f minus L is less than minus epsilon over k, where k is less than 0. Okay, so this is actually the same because we just need to multiply minus k to both sides. Minus k is a positive number since k is less than 0. So minus k, f minus L is less than positive k epsilon over k. And put this into the absolute value, so still the same. The sign changes. Not the same, sorry. So still the statement holds. And the third one, k equals 0. So limit x to c 0 equals 0. Like this is shown in the previous video. Like limit x to c, k is k. Okay? You just need to take delta to any real number. Then this statement holds since epsilon is always greater than 0. Okay, so number 3 will be product rule. Then it says that if limit x to c f of x is L and limit x to c g of x is m, then limit x to c f times g is L times m. So we want the inequality that f times g minus L times m less than epsilon holds. We want this to hold, okay? So we can start from this inequality, and we can know that f of x is equal to f of x plus L and minus L, right? Then g of x is equal to g of x plus m. And minus m. So Lm still. Then we change the order here. We change the order here. So we have that L plus f of x minus L times m plus g of x minus m. Then Lm is still here. Okay, so we change the order in the first equal sign. Then the second equal sign will be multiply them, okay, directly. So here we have Lm, and here we have L times G minus M. Then here we have M times F minus L. And here we have F minus L times G minus M. And minus Lm, okay? And cancel these two. Cancel these two. So we have this absolute value, okay? And please tolerate me for just erase these two because this is a little bit long then, and the space is not enough. Okay. So we have some conditions since there are two given limits. So the first will be there exists delta 1 in the inequality. Then the limit holds. So we know that F minus L is less than any arbitrary real number, positive real number. So the first we take square root of epsilon over 3. You may think that this is weird. Yeah, this is very weird, but you will know why we take this number. And there exists delta 2 in this inequality as well. So this delta 1 corresponding with this limit. So this delta 2, I think maybe corresponds with the second limit, g, okay? So g of x minus m is less than, still the same, epsilon over 3, the square root of epsilon over 3. Okay, and there exists another 2. Let me write it quickly. The space is a little bit not enough, okay. You will see why I take these deltas, or epsilon. One of the reason is that we want a clean epsilon in this inequality. We want to show this limit holds. So we want a clean epsilon, like here. Okay. So let this to be I. Okay, I. Because this is too long. So, okay, let's look at I. So I is less or equal than. Let's apply the triangular inequality. So this is the first item, the second one, the third one. Okay. So the first one, L times G minus M. Okay. And plus M minus F, M times F minus L, then G minus M times F minus L. Okay, so here G and F stands for G of X and F of X. So we can put the absolute value. We can take the L and M out from the absolute value. So this is equal. Almost done. And because we don't know like L and M, we don't know what they are, what value they are. So we just put 1 on it. So 1 plus the absolute value of L times G minus M plus 1 plus the absolute value of M times F minus L, then plus this thing. So okay, so we have the the 4 epsilon here, okay? So we just need to take delta, which is the minimum of the 4 deltas. So that means if we take the delta into the least one, it least 4. So least inequality all hold, okay? So here g minus m is less than, okay, so you can see here and here, right? The value, the multiplier canceled. So here we can have, oh, critical mistake. Critical mistake, okay. This is correct. So which is less than epsilon over 3, okay? So look at the second one, epsilon over 3 as well. And the third one is tricky. It's a little bit tricky because these two multiply together, then we get still a epsilon over 3. So these 3 combine together into an epsilon. Therefore, this statement holds. Okay, so this is product rule. Okay, the last one will be reciprocal rule. Reciprocal rule says that if limit x to c g of x is m, which is a finite value and it is not 0, then limit x to c 1 over g will be 1 over m. This is kind of like trivial, but the proof is a little bit hard. So we want the inequality that g, 1 over g minus 1 over m is less than epsilon. It's true. We want this statement, this inequality to be true. Okay. So let's start from the initial condition. The initial condition says that the limit of g is m. So we can have g minus m is less than epsilon, right? Because this is given. So this is less than epsilon, any positive real number. So this is, of course, less than the absolute value of m over 2, right? Then we apply the triangle inequality once again. So we can have the absolute value of g minus the absolute value of m. Then the absolute value of these two, which is less than g of x minus m. So these two are the same, okay? These two are the same. Then the a here is g, and b here is m. Triangle inequality. Okay, so we know that this is less than the absolute value of m over 2. So we can have this inequality. Then we break the first absolute value. So we can have the absolute value of g minus the absolute value of m, which is less than the absolute value of m over 2 and greater than minus absolute value of m over 2. M plus absolute value m in these 3 parts. So this inequality shows, okay. Then we multiply 3 parts by 2. So we can know the range of g, of absolute value of g. Okay, so later we divide absolute value of m and g. So here we have g of x, the absolute value of g of x, 1 over absolute value of g of x, which is less than 2 over absolute value of m, and 3 over absolute value of g. Okay. Get back to the goal that we want to have is there exists delta such that g of x 1 over g of x minus 1 over m, which is less than epsilon, right? So simplify this part first. So we can have m times g of x, then m minus g of x, the absolute value, okay. Then we put the denominator out. So 1 over the absolute value of m times 1 over the absolute value of g times m minus g. Okay. And here we have the inequality, right? So this part is less than this part is less than this part. Okay, so we just need to take g minus m. From this condition, we need to take g minus m less than a square of the absolute value of m over 2 times epsilon. Then this, which is what we want to show, is less than epsilon. But if you put this part, if you put that part here, then the constant, aside from epsilon, the constant all canceled out. So this is the end of the reciprocal rule. And also the quotient rule is proved as well, because we can use product rule and reciprocal rule to prove quotient rule.